In this video, we will be simplifying square roots using the product property. Now I notice under the square root sign here, I've got a 75 times y to the 29th. So because they're multiplied times each other, the product property tells me that I can split them out into individual factors. So the first thing I'm going to do is rewrite this as the square root of 75 times the square root of y to the 29th. Now let's see if we can simplify this any further. The square root of 75 by itself is not going to yield a perfect square, but I could probably split it down into factors. And when I do that, I want to look strategically for factors that are perfect squares. So one thing I see is that 25 is a perfect square, and it is also a factor of 75. So I could take this 75 and break it down into 25 times 3. Now the product property again says I've got these two things multiplied by each other, these two numbers, so I'm going to split them into their own individual square roots. So this is helpful because now I can take the square root of 25, which is 5, times the square root of 3. The square root of 3 can't be simplified any further. Don't be tempted to go to your calculator and calculate what is the square root of 3. It's some irrational number, and it's going to be a decimal approximation that your calculator gives you. It's not an exact value. Because we want an exact value, we're going to leave it as the square root of 3, and it can't be simplified any further. Now let's do something similar with square root of y to the 29th. Bring everything up here and rewrite it. Now again, when we take the square root of y to the 29th, we want to split it into factors, looking for something that is a perfect square. Now, because this is a square root, if we have an even number on this exponent, then that's going to be a perfect square. So I think that it would make sense to split this y to the 29th into y to the 28th times y. That's the same thing as y to the 29th, but when I split it apart like that, again, we can use product property and do individual roots here. Now, why is this a perfect square? Well, if you think about this a little differently, the square root of something is the same thing as taking something to the 1/2 power. So if we rewrite this y to the 28th, instead of a square root, write it to the 1/2 power, notice that we have a power to a power, 28 to the 1/2, so we can multiply them. 28 times 1/2 is y to the 14th. You don't have to do this step where you rewrite it as a half power, but just realize that when we take the square root of something to an exponent, we can take that exponent and cut it in half because of this. So now we've got 5 times the square root of 3 times y to the 14th times the square root of y. I think that each one of these pieces is simplified as far as it can go. The last thing I'm going to do is recognize that I've got these two square roots, so I can kind of squish them together into the same square root. This is again an application of the product property. And I have simplified that expression as far as I can go.